Okay, x, y intercepts for rational functions. So finding these guys for rational functions is no different than any other function that you're used to. All you have to do is for your x-intercepts, you just have to set f of x equals to 0 and solve the equation. For y-intercepts, you just plug in 0 as x, so sub x equals 0, and find what f of 0 is going to be. So the y-intercepts are not very interesting. You just substitute 0 and you find the number. But the x-intercepts are slightly more interesting for rational functions, because sometimes you actually won't get any. We'll do those examples right now. So over here we have 4 examples. We're going to do the first 2, because these guys will illustrate that we're not cases that we don't have any x-intercepts. So let's do them. Alright, so the first one, we can do f of x equals 2 over x minus 4. So if you want to find the x-intercept, you just set f of x equals to 0. So 2 over x minus 4. Oops. Okay, 2 over x minus 4 equals to 0. Okay. 1 second. I did some stuff. Okay, we're back. So once we set equal to 0, we have this type of equation. So we can take care of the fraction at the the denominator at the very bottom by multiplying both sides by x minus 4. And since 0 times anything is 0, if we multiply the right side by x minus 4, we're still going to get 0 on the other side. So we're going to write equals to 0. And now since we multiplied x minus 4 on this side, this guy is now cancelled out. So we're going to get 2. So this is kind of weird, right? What this is saying is 2 equals 0. And what this means is that we actually don't have any x-intercepts. This thing is nonsensical. So because when we try to solve for this, when we try to put 0 into our function, and we get something nonsensical, what that means is on our actual function, it's impossible for us to get any x-intercepts. So once you get something like this, something that doesn't really make any sense, we can just say that there are no x-intercepts because 2 does not equal 0, therefore no x-intercepts. So the shorthand for this, or what you can actually figure out instead of solving your equation or setting equal to 0, you can actually figure out whether or not your rational function has any x-intercepts by just seeing if at the numerator, if it's just a number or not, if there's any x's. So in this case, since 2 is the only number in our numerator, there's no x's or anything else, we can already tell that this doesn't have any x-intercepts. And this work over here is just to showcase to your teacher or whatever that you're not pulling something out of your ass. Yeah, you're proving it. So if you look at our next example, we can actually tell whether or not it has a x-intercept or not based upon what we figured out. So, yep, our next example is this one. Oops, this one. So you can see at the very top, our numerator is -4. There's no other x's or any other variables. So we can already tell that this guy would not have any x-intercepts. So let's do it. Let's prove it. Once again, we have f of x equals to 0. We have -4 over x squared minus 4x plus 5 equals 0. Okay, and then -4 equals to 0. We can multiply both sides by the entire denominator here. This is a trick that you can do. So once you multiply this whole thing to the other side, 0 times whatever is 0. So this is pretty much gone, 0. And then, yeah, So once again, we have negative 4 equals 0, which doesn't make any sense. We already know this. So therefore, since negative 4 cannot equal to 0, that means that no x-intercepts. Good stuff. Okay, so let's graph these. And, oh, right, we didn't do y-intercepts yet. So for y-intercept, all we have to do is substitute x as 0. We have 0 squared minus 4 times 0 plus 5 to get our y-intercept. We have, oops, that was an oops. Okay, we have negative 4 over 5. So that means that our y-intercept is going to be at negative 4 over 5. Okay. Okay, so let's graph these. Let's type in the one that we just did. That's x squared minus 4x plus 5. Nice, here we go. So as you can see, our function does not have any x-intercepts, as we foretold. There's a horizontal asymptote at 0, and you can see always the function, it's really close to 0, but never crosses it. So we can prove this by staying all the way out here. And as you can see, well, this is technically not 0. Desmos is just rounding. So if you see over here, you can zoom in even more. Let's keep zooming in. There you have it. So it gets really close to 0, and it's always going to get closer and closer to 0. These decimal places will get, even smaller. But yeah, always gets close to 0 but never crosses it. So we don't have any x-intercepts. In our y-intercept, we said was 0 and negative 4 over 5. And here we have it. This is our y-intercept, and negative 0.8 is negative 4 over 5. You can put it into your calculator and confirm that. But yeah, that's pretty much it. Let's do the same for the other one. So the other function we had was, I forgot what it was. Let's see. It was 2 over x minus 4. Alright. So as you can see, we have our asymptote action once again. We have our horizontal asymptote at y equals 0. We'll be learning about those soon. Yep, and the function gets close to 0 but never crosses it. Okay. And we haven't found the y-intercept for this, but if you put 0 into our function, if you imagine it, setting our function, our x value equal to 0, we're going to get negative 2 over 0 minus 4. And once we simplify it all, we're going to get 1/2. And as you can see, our y-intercept is at 1/2, 0.5. Okay, so let's do some examples where we are actually going to get x-intercepts. The other two examples we have are these ones. So let's get the x-intercepts. The process is exactly the same. You just have to analyze what the result is. Alright, x over 3, 2x minus 5, x plus 6. Okay, so if you find the x-intercept for this, we just do this, say equal to 0, x minus 3 all over 2x minus 5, x plus 6 equals to 0. You can multiply both sides by 2x minus 5 and x plus 6. Since 0 times anything is 0, you'll just have 0 on the right side. And then on our left side, everything in denominator is now gone. So we get this nice equation x minus 3 equals to 0. X equals to 3. Sweet. So in this case, we actually have something that made sense, because our numerator, if you notice, does not only contain numbers, it also contains x's. So when we solve this equation, when we set it equal to 0 and we solve it, we're going to get an x-intercept, which is at 3 stuff. And then we can get our y-intercept. We can do the same thing as before. F at 0 equals to 0 minus 3 all over this stuff. 0 plus 6. The top you get negative 3. The bottom you get negative 5 times 6. And this works out to be 1 over 10. Let's graph this one and see what we have. So here we have Desmos. Let's graph our function. X minus 3 all over to x minus 5. And then x plus 6. Awesome. So as you can see, we have a x-intercept at 3 and 0. You might be wondering what this point is. This point is not x-intercept, it's just like slightly above it. And that's the only x-intercept we have. Our function does this thing where it goes close to our horizontal asymptote once again, but never crosses 0. Same thing on the left side. And our y-intercept we got as 1 over 10. We can see that this one is indeed 1 over 10. 0.1 is 1 over 10. And there we have it. Okay, so let's do our last example. Alright, so our function we have is this guy, x 2x squared minus x minus 15 all over x plus 6. So our process is going to be exactly the same. To find our x-intercepts, we just sub in 0 and solve the equation. Okay, x plus 6. Multiply both sides by x plus 6. We have 0 on one side, so that's gone. The bottom is gone. 15. Okay, and yeah, even though it's a quadratic, we know how to solve quadratics. We just have to factor it and then get our two factors. So we have 2x, oops, yeah, let's do this. 2x plus 5, yeah, x minus 3, 0, x equals negative 5 over 2, and 3. So that means we'll have two x-intercepts, one at negative 5 over 2, and one at 3. Alright, and then let's get our y-intercept. We just have to sub in 0. Okay, let's boxes first. So f of 0 is 2 0 squared minus 0 minus 15, 0, oops, 0 plus 6, this is negative 15 over 6, negative 5 over 2. Okay, that's our y-intercept. Alright, let's go to Desmos and confirm this, just so we can see once again how to, just see it once again. So, let's put in Desmos. We have 2x squared minus x minus 15 all over x plus 6. Okay, so this is what a rational function looks like. We kind of zoom out, we're going to get our weird shape of the graph. But all we care about right now is our x-intercepts. You can see that there are two of them, one at 3 and at negative 5 over 2, which we got over here, and our y-intercept, negative 5 over 2. So yeah, process is exactly the same. How you get x-intercepts across the board is you just set your function equal to 0 and you solve the equation. Same thing for y-intercept, you substitute x as 0 and you solve for the y value. And that's it.